Okay. Our warm-up involved similar stuff. Without solving, tell which method you would choose to solve each system. Graphing, substitution, or elimination. Explain your answer. 17. What do you think, Marina? Very good. Substitution. Why, Marina? Marina said it best, because the y is already isolated. It's on that one side by itself. So all we would need to do is take that 2x minus 5 and plug it in for that other y. All right, Steven, what do you think for number 18?
Elimination.
Excellent. Why is it elimination?
Because both equations have 7x.
Ah, the 7x is the same. All right, Steven, the million-dollar question. Do we add or subtract these equations?
Add.
Very good. Why?
Because they are opposite, so if you add them together, they cancel.
Yes, they are opposite. The 7 is positive on the top one, and the 7 is negative in the bottom one. So they are going to cancel when we add them, not subtract them, okay? That was a nice, cute little recap of 6.4. Let's dive into 6.5. 6.5, we're doing systems, but with inequalities, okay? Linear inequalities. Let's do it. Okay, our objectives are to graph linear inequalities in two variables, to use linear inequalities when modeling real-world situations. When you guys hear inequality, many of you guys think about like protests, riots, people aren't being treated the same. We can think about that similarly with math, but it's not an exact correlation, okay? When we talk about inequalities in math, it's basically saying one thing is less than another or one thing is greater than another, okay? It's not an equal sign anymore. It's going to lean towards one side or the other side. And if you take a look at that handy-dandy picture down in the bottom left, that is an example of when we graph an inequality. We've seen inequalities where it's like 7 is greater than 5, 4 is less than 9. But when we graph them involving variables, I'll show you guys exactly how we do that, okay? One side of our graph is going to be shaded, which will include all the solutions. The other side will not. All right, peeps, let's do this. So guys, take a look at this graph, okay? This red line is the equation y equals x plus 2, okay? So in order to graph an inequality, you're just going to take the inequality, wherever you see the inequality symbol, replace it with an equal sign, okay? So this is y equals x plus 2. Now, since the symbol that was used was less than, okay, that means we are shading below our boundary line. So this red line is called our boundary line. Since y is going to be less than x plus 2, we're shading below, okay? If y was greater than, we would shade above, okay? And once we start to do some examples, this will make a lot more sense. And on that note, a linear inequality in two variables, such as y is greater than x minus 3, can be formed by replacing the equal sign in a linear equation with an inequality symbol. A solution of an inequality in two variables is an ordered pair that makes the inequality true. Very similar to just regular equations, okay? Essential understanding: a linear inequality in two variables has an infinite number of solutions. These solutions can be represented in the coordinate plane as the set of all points on one side of a boundary line. Once we're done copying down these definitions, we're going to go back one slide really quick, okay? Okay, let's go back one slide, do an example. So jump to slide number 3, identifying solutions of a linear inequality. Is the ordered pair a solution? So in these types of problems, we're just gonna plug in whatever we have for x, whatever we have for y, and see if our inequality holds. So our inequality is y is greater than x minus 3. We plug in 1 for x, because this is our x value, and we plug in 2 for y, and we see if it holds. So this is gonna be 2 is greater than x, which is 1, minus 3. Anthony, is 2 greater than negative 2?
Yes.
Yes. Boom, bada bing. We're good. So we can say 1, comma 2 is a solution. Simple. B, negative 3, comma negative 7. So this negative 3 is going to be what? X or y? X. The negative 7 is going to be? Y. We plug them in. So it was y is greater than x minus 3. Instead of x and instead of y, we've got negative 3 and we've got negative 7. So is negative 7 greater than negative 3 minus 3? Put our parentheses when we're plugging in. Negative 7. What is negative 3 minus 3? Negative 6. Which one's bigger, negative 6 or negative 7? Negative 6 is bigger. So is this statement true or false? False. Okay, this is not a true statement. So what we write is negative 3, comma negative 7 is not a solution.
Please pardon the interruption. Tennis team may be excused at this time. Tennis team may be excused at this time. Thank you.
Good luck. Negative 3, negative 7 is not a solution. So those are pretty easy, right? It's giving us the point. It's going to be like, is this a solution? We figure out if the inequality holds, if it doesn't hold. And we're all pretty good at determining whether one number is bigger than another, okay? All right, next one. Is 3 comma 6 a solution of y is less than or equal to 2 over 3x plus 4? Well, all we got to do is plug them in. What is 3, x or y? What is 6? We plug those in. What's my new inequality going to read, Bradley? Without y and without x. Without y. Without y. I don't want y anymore.
3 minus 6.
No.
6 minus 6.
Wait, what? You said 3 minus 6?
Yeah.
Why?
No, I said 6 minus 6.
Marina.
It would be 3 is less than 2 over 3 times 3 plus 4. I'm pretty sure.
Like this?
Yeah.
Only one mistake. What is it, Joaquin?
You're gonna have the 3 and the 3.
Okay. The first 3.
I said 2 and 3, so like,
But wait, where'd that 6 go? Luciana?
Oh, the 3.
Where the 3 should be, right? On the other side. So instead of a 3 here, we need to have a 6, okay? Because remember, y was 6. So wherever we see y, we're plugging in 6. Wherever we see 3, we're plugging that in for x. Okay, so we've got 6 is less than or equal to 2 over 3 times 3 plus 4. Who's good with fractions? How do we simplify that right side?
multiply
Uh-huh.
by 3,
Uh-huh. What happens?
6.
Okay, so 6 is less than or equal to, this becomes 6
Multiply by 3. Wait,
plus 4.
yeah.
This is 6 plus 4? 6 over 3. There we go. 6 over 3. Because remember, if this is a fraction, right? 2 over 3 times 3 is the same as 2 over 3 times 3 over 1, right? We multiply the 2's together. The 2 and the 3 together. We multiply the 3 and the 1. We get 6 over 3. Okay? Remember, when you're multiplying fractions, you multiply across, right, Amanda? Okay, so if we multiply it across, we get 6 over 3 plus 4. Nick, what is 6 over 3? We can simplify that, right? I thought I called Nick's name. 2 over 1. Very good. Which is the same as just 2. So 6 is less than or equal to 2 plus 4. Is 6 less than or equal to 6? Amanda? Yep. So what we can say is 3, 6 is a solution. We're just plugging and chugging, boys and girls. Plugging and chugging. Right, Natalia? Yep.
Can I go to the nurse's office?
Mm-hmm. Okay. Graphing an inequality in 2 variables. Guys, this is where, if you were taking a little mental break, I need you refocused, okay? What is the graph of y is greater than x minus 2? Pay close attention here, okay? We're going to write down a few things. If you have a greater than or a less than symbol, I need you to write down that that's going to be a dotted line. If you have a greater than or equal to or a less than or equal to symbol, that's going to be a solid line. If you have a greater than or equal to, that's going to be shaded above. And if you have a less than or equal to, shaded below. Okay. So how this works, what we're going to do is we're going to treat this y is greater than x minus 2 as y equals x minus 2, okay? This equation is in slope-intercept form. What's my slope, Brooke? One. Luciana, what's my y-intercept? -2, okay? So we're going to have to plot this point and use that slope to figure out our boundary line, okay? This is what we're going to call our boundary line. So we've got our y-axis, our x-axis. Where should my first point go? Daniil, where should my first point go? Amanda, where should my first point go? At -2. And what axis, the y or the x? The y. So we're going to go down 2 and put a point right here at -2. Okay? And my slope is 1. So I'm going to go up 1 over 1. Up 1 to the right 1. Up 1 to the right 1. So my line is going to look something like this. So it goes through -2 on the y-axis, and its slope is +1. We've done this before. We've done this like 100 times probably. But now we have to follow the rules that we set for ourselves for our inequalities, okay? So this is a greater than sign, okay? So looking at the first two scenarios, are we gonna have a dotted line or a solid line? Which category does it fall under? Does it fall under the dotted line category or the solid line? Marina? Dotted line. So what you're going to do is just take your eraser and just erase part of this line, okay, to make it a dotted line. And for some reason, it's not working. There we go. I can zoom in now. Take your eraser and erase part of the line to make it a dotted line. Okay. Next, we also have to check if we're shading above, if we're shading below. It's greater than, right? So which category does it fall into? Shaded above or shaded below? Jordan? It's shaded above, okay? If it's greater than, it's shaded above. Do you see how this is a greater than symbol? We're going to shade above our line. If it was the other way around, we would shade below. So above our line is anything on top, okay? So let's just take a highlighter and let's just shade the region above this line.
Like everything, like.
Yep, all the way up to the end of the graph. What this shaded region represents, guys, is it represents all of the possible points that would be solutions to this inequality. All of the possible points that would be solutions to this inequality. So take the point, I don't know, 0, 0, right here at the origin. Do you guys see this point? Is that in the red region?
Oh, yeah.
Yeah, it is, right? So this should be a solution. Let's check it out. So if we plug in for 0 for x and 0 for y, it should be a solution. We're trying out 0, 0. So 0 is greater than, we plugged in 0 for y, we plug in 0 for x minus 2. Is 0 bigger than -2? Yes. Let's pick a point that's outside of the shaded region. Can anyone tell me a point that's outside the shaded region that is not in red? Give me any point. What's that? 5, -5. So 5, -5 would be here and then down 5. Yeah, it's like somewhere way out here. Let's try out that point. 5, -5. So for x, we're plugging in 5. For y, we're plugging in -5. -5 is greater than 5 minus 2. Is -5 bigger than 3? No. So it's not a solution. Do you see how all the ones that are not going to be solutions are going to lie outside the shaded region? All the ones that are solutions are going to lie inside the red region. Okay? You with me, Marina?
Yes.
Okay. What is the graph of y is less than or equal to 1/2 x plus 1? Well, y, let's start off by just writing y equals 1/2 x plus 1. What's my slope? Bradley, what's my slope? 1/2. What's my y-intercept, Jordan?
Y-intercept is 1.
Mm-hmm. So I'm going to write my graph. Y-axis, x-axis. What's the first point I should put on my graph? Joaquin? What's the first point I should put on my graph? Steven?
1.
And what on what axis?
0, 1.
0, 1. Good.
Yeah.
Right here. At 1 on the y-axis. So there's our point. Our slope is 1/2. So that means our rise is 1. Our run is 2. Our rise is 1. Our run is 2. So we're going to rise up 1 unit. And then we're going to go over 2 units. So here's our next point. 1, 2 more over, and 1 more up. Here's our next point. And we just draw a line through all of those. All right, guys, now we have to figure out if it's going to be a solid line or a dotted line. And how we figure that out is we look at this. If it's equal to, it's going to be a solid line. So we don't have to change anything, okay? If it's only greater than or less than, it's going to be a dotted line because it's not going to include the solutions on that line. In this case, since it's equal to, we're going to include those solutions. So that's going to stay as a solid line, okay? Now, it's less than. So are we going to shade below or above? Below, okay? So we're going to take out our highlighter and just shade everything underneath the line. And nothing above the line. And then let's check it. So give me a point that's in the blue region that we can check. Any point. Joaquin? 2, -3. Love it. 2, -3. That would be 2 units to the right, 3 units down, so somewhere over here. That absolutely lies in the blue region. And let's check it. So is 2, -3 a solution to our inequality? So we've got y, which is now -3, is less than or equal to 1/2 times 2 plus 1. -3 is less than or equal to 1/2 times 2 is just 2 divided by 2, which is just 1 plus 1. So this is -3 is less than or equal to 2. Does that work? Is -3 less than 2? Yes. You with me, Bradley? Okay. How you doing, Brooke? Anthony, make sense? Kind of? Should we do a few more? Okay. The only other thing that you guys need to know in this lesson is when it's like one variable and a number. So x is greater than -1. You're still going to treat it like x equals -1, okay? So we're just going to write in x equals -1, and we're going to graph it. So remember, when x equals -1, is that a horizontal or a vertical line? Who remembers? Anyone remember if x equals -1 is a horizontal or vertical line? Marina?
I think it's horizontal.
You think it's horizontal? It's a vertical line, okay? So but if you can't remember, right? Just go to x equals -1 on your axis. Here's -1, right? On the x-axis, just draw a line at -1. Now, if x has to be bigger than -1, we're going to shade everything to the right of that line, okay? Because x values need to be bigger than -1. So let's shade everything to the right. So this is our solution. The only thing I'm missing is whether it should be a dotted line or a solid line. This was x is greater than -1, so it should be a what, Stephen?
Dotted.
Dotted, very good. So we're just going to take away with our eraser some of these parts of the line to make it a dotted line. Don't forget to make it a dotted line, guys. Okay. And lastly, we've got B, which is y is greater than or equal to. Why doesn't it? Let me move around when I'm on the eraser. Y is greater than or equal to 2. So y equals 2. Always replace that inequality with an equal sign to begin with. Here's our x, here's our y. Y equals 2, horizontal or vertical line, peeps? Well, if x equals -1 was a vertical line, y equals 2 should be a horizontal. Okay? It's going to be a horizontal line. Just find y equals 2 and just draw a line there. Amanda, solid or dotted line?
Solid.
Solid, very good. Why?
Because it has like the equal to.
Good, it has the equal to sign. And we're going to shade above or below. Brooke. If y is greater than or equal to 2.
It would be
Above. Good, right? Because if you think about it, what are all the values that are greater than 2? They're going to lie above that line, correct? For y. So we have to shade above that region.